Let's start. Welcome everyone again to our webinar, The Aircraft Stand of the Future, together with our partner Springshot. Today with us is Doug, the CEO and founder of Springshot. Then we are also very happy to welcome Massimo Cicetti from IATA and our own Dr. Nikolay Kobyshev from Assaia, the CTO and co-founder of Assaia.
Hey there, everyone.
What we will do today, so basically we will go through a very, very brief introduction and then directly go into media res. First is Massimo giving us some insights about stats and figures and also some of the initiatives that IATA is driving in order to create the stand of the future. Then Doug will present Springshot's views on this topic, followed by Nikolay, who will give a little bit of insight of what can be done with computer vision in order to create the stand of the future. This is not supposed to be any kind of sales event, so we really focused in the beginning to present valuable information that is generally interesting. So I hope you think the same. In general, I would be very happy, or we all would be very happy to get your feedback in the end. What can we do better? What was already very good? Because we do plan to have more webinars in the future. Nikolay, please.
Yes.
So just to give you the bigger picture, as you can see here, the whole aviation industry and everything around aviation, there's a lot of stuff happening. You have landside, you have airside. So these are all different aspects. Some of them we want to cover in future webinars. And today, as I said, the stand of the future. So we are primarily looking at the area outside terminal on the airside level. And they're primarily about ground handling operations and tarmac. All right, then coming to the introductions, I would like to hand over to Doug to please briefly introduce yourself and Springshot.
Yeah, hi, thanks, Samuel, and good morning, good afternoon, everyone. I'm Doug Kreuzkamp, founder and CEO of Springshot. We look forward to sharing more today on how we see turn operation technology evolving over the future. At Springshot, we think we bring a humanistic perspective to the conversation. I and many of my colleagues, a couple are on today, Clint Powell, our Chief Customer Officer, and Roshan Patel leads product. But many of us began our careers in aviation as ground handlers. And over the years, we've seen how this experience provides us an ability to approach airport ops technology largely from the vantage point of the human crew member. And so we look forward to sharing our insights on that approach today. Also, how we see emerging collaboration technologies truly transform the crew member turn experience.
Thanks, Doug. Massimo, please.
Yes, thank you, Ian. So good morning, everyone. My name is Massimo Cicetti. I'm Senior Manager, Ground Operation, Automation and Digitalization at IATA. I will talk today about the IATA initiative called CEDAR, Connected Ecological Digital Autonomous Ramp, that we have started 1.5 years ago with a concept. We have done some boot camps and then we put together some work plan that I will explain during this day. So it's a pleasure to be hosted here in this Assaia webinar. We are cooperating each other throughout our working group, and it's a pleasure to be with you guys. Back to you, Jan.
Thanks, Massimo. And last but not least, Nikolay, please.
Hey there, everyone. My name is Nikolay. I'm a CTO and co-founder of Assaia. As I think all of you know, Assaia is specializing in using computer vision for monitoring on what's happening during the turnaround. You will know a little bit more about that in the later session. I will try to show you a couple of examples of what can be done just with computer vision on the stand. Hope you will be excited by that.
Cool. Then I would say let's start. First in line is Massimo about the CEDAR project.
Thank you, Ian. So we can start here with a brief video. It's about 2 minutes that explain a little bit what is CEDAR is about. So I think we can go with the video and then I will follow up with the rest of the presentation.
Current forecasts predict exponential growth in air travel. Passenger demand is expected to double over the next 20 years. Over 38,000 new aircraft will enter the skies during this time. Airports are going to be really pressed for space, pressed for clean air, really busy, and really, really noisy. Airport extension is not the only solution. We have to work smarter. Aircraft are already connected to the ground. We just need to connect them to operations in smarter ways. Digitalization will facilitate the exchange of data in real time. Information will complement human-to-human with machine-to-machine interactions. Predictive analysis will enhance our capability to accommodate more traffic and improve our turnaround performance. Every person and piece of equipment needed for the turnaround is checked for compatibility with the arriving aircraft and will be available to perform their function in the right sequence. The right equipment, the right people, in the right place at the right time. Our developing technologies are not only about just in time or being efficient. All of our equipment, right from the aircraft through to the smallest tractor, is potentially capable of running cleaner and being less noisy. New generation batteries and alternative green fuels are already making this possible. Even aircraft can switch off their main engines and taxi on electrical power. Electrical control systems are becoming more precise, which is enabling more autonomous operations. This is how we see our ramp of the future. This is CEDAR, a connected, ecological, digital, autonomous ramp.
And here is CEDAR. So we can move here to the next slide. And I want to start to give a little bit of a key context. So why IATA has started to engage with such a project and what is the rationale behind this. So what you see in this chart actually are airport and airport works for expansion. So we have over $1 trillion of US investment either for expanding existing airport or to building up a new one. So what you see here, the red dots are airports that have reached their maximum capacity of demand. They cannot host more traffic, although they have requests to have, more airline and more flights to go into it. The yellow one are the airport that instead are trying to expand their facilities, whether this is from new runways or new stands. And the green one are airports that are start to be brand new airport built up to accommodate more traffic. So move to the next piece. What we are representing here is some stats and some business cases that we have done pre-COVID crisis. Now, all the forecasts now need to be reviewed, but we think that in 1 year or so, we can start to think that the same pace of growth will be started again. So the COVID is just going to be something that is in between like a disruption, but then the overall traffic growth will continue to grow. The expectation is to have from 3.3 billion of passengers to 6.7 billion of passengers in the next 20 years. Here we have a new plane that are coming into the market. This is taken from the forecast of aircraft, Boeing and Airbus, and this is the net figure. What does mean net figure? That this is taking into consideration also the number of aircraft that is going to be phased out. So if we move instead to the next slide and the next figure, what we can see here is the elements of the CEDAR project. So what we're looking at a holistic approach and trying to connect everything, because what is important to understand, how can we connect and make it all the operation more efficient, and especially why IATA is embarking into this. So we are not selling any solution. We are not a solution provider, but we want to help as much as possible our members to save money and to make more efficient and better organization of the work. To do so, we need to consider the various elements. One is the airport infrastructure. So now we'll go through that detail of the stand design that has not changed in the last years. The ground support equipment, all our opportunities also to use equipment that is green, that is a reduction of noise and pollution. We have recently conducted a study with the Research Institute of Germany, and we have now figures how much we can do as a change also in the green aspect. The aircraft, of course, is at the center of all the concept, and we need to work with the aircraft manufacturers to enhance and to help. All the solution to work well as a unique solution. Internet of Things, sharing of data, that's where we see also our leading role. So we can move to the next slide. Not just, for us into creating any particular solution, but we see here the different technology that now is used on the ramp or is going to be used on the ramp. We have robotics, we have the ramp mobility, which is a very good topic, to enhance the way we're going to track, all vehicles and people that are working on the ramp to assist aircraft. The artificial intelligence, that will have our speakers further on that will explain way better than me what is this about and what are the solutions. Data standard format, that's what we are trying to work to connect all solution providers, all people that are working in aviation that are providing great solutions to distribute and use the same format of data so that we don't have to incur into huge cost of integration about different systems that capture different data, and we can do everything in a unique way. That's what we're trying to do here. We have some standard that we are starting to developing this year together with the new established group GAD, Ground Operation and Automation Digitalization Working Group in IATA, that we are recently kicked off. We can move to the next slide. And here we see the sad reality between, the ramp and the passenger's experience. A lot of things are automated into the passenger's experience, a lot of mobile application, real-time information. What we do have instead in a ramp is still a very old-fashioned communication tool, GSC. Information about the turnaround are not shared in real time with all providers, primarily airport, ground handling providers, and airlines. All have to contribute with giving data and sharing data at the same time. The infrastructure sometimes is still old-fashioned, so the stand design has not changed much. And also, particularly in some countries, the pollution is increasing and increasing. So we have a lot of opportunity, not only from an aircraft perspective to reduce CO2 emissions and noise, but also we do have a big opportunity in ground support equipment. Move to the next piece, please. Now, what is the reason and the rationale why IATA is trying to work with all stakeholders in CEDAR? The reason is that ground operation does not generate a penny of revenues, but ground operation generates a lot of cost. So we are only a cost in our domain. So what is our chance here? Our chance is to reduce those costs and make our operation more efficient and more safe. There is a lot of talk in the years about safety, ground incident, operational, injuries and so on. But how much are the money that we lose into inefficiency? It's actually even more than the one that we lose on safety. Now, this is just a little bit of an example of delays. So the spreadsheet that here I'm showing is the delay that is generated only by ground operation. So we have one bucket, is 5.8 billion as of today. That here we have the forecast that include the traffic growth, of course. And we have a reactionary delay. So the chain of delay that we bring after we have started with the first flight and delay in ground operation. So overall, we are around $14 billion as an industry of delays that we can save. So here, the assumption is that if we have a better data sharing, if we have a better integration of system, and we can prevent such delays to happen, or we can work in a way that we can act at the moment we know the information, know what once things have happened. Just thinking about saving 5% of delay and projecting in 20 years, then our opportunity can be between 5 and 11 billion, depending how we will be good in reduction of those delays by introducing automation, introducing digitalization, data sharing, and information. Let's move to the next piece. This is the second bucket, ground damage. How much is cost ground damage? Actually, we have finally conducted our final forecast. As of today, we are around over 5.7 billion, 5.2. Now we have refined a little bit the figures from this chart. That's our cost, indirect cost primarily, plus the direct cost, which is less. If we introduce here automation only with proximity sensors, warning device, and cutoff devices, we can reduce already 10% only with simple solution and technology that is there in the automotive industry ever since. So this is not a big difficult to do so. So if we take this into our opportunity to reduce that in automation and we project into the forecast, here we can reduce 2 billion in the next 10 years. Let's move to the next piece. So the next piece of the business case is the cost per turn, which is actually the highest cost for ground operations. So as a starting cost, we have 43.3 billion as of today, compare number of movement divided into narrow body, wide body. Of course, the number we have shown here has been kind of a merge of different costs between different regions. So divided by narrow body and wide body. So we have here an average cost per turn, which is only the direct cost for ground handling to supply the services. It's not the cost that the line purchased from the ground handler, which is much more. So here, if we introduce automation, if we remove some of the process that we are now doing manually, and we automate those processes, whether by the use of digital or robotics, well, actually also here, our opportunity can be 10 billion in the next 10, 15 years, depending how fast we will be in the introduction of this automation. Also, sometimes even more simple solution in a big airport, ground support equipment sharing reduce a lot the chaos and the number of vehicles that are moving back and forth. So that's also opportunity, not only by introduction of technology, but they have a better use of it. The next slide. Here we have the capacity of the airport, of course. If we are able here to predict, the stands and to reallocate the stands in a smarter way by having in the real-time information about the status of a given turnaround, of all delays, so that an airline is supposed to include here the information and data about weather condition or emergency response, anything ATC situation that can change or disrupt a turnaround of a series of turnaround. Actually here, we have a better way we can handle the stands and the turnaround in our airport, and we can increase the capacity of the airport without expanding. So here is just, a saving cost that we are here forecasting. And here again is depending how fast or how successful can we be in introduction this technology, automation, and innovation. The last piece, which is occupational health and safety. Now, it's very difficult to talk about cost when we talk about human life, when we talk about injuries, but there's, fixed cost that does not take into consideration fatalities. So we are not, of course, assigning a dollar figure to a fatalities to a human, or if you have a severe injury, what is the overall, situation for the employee. We just have purely costs for, insurance cost, and all those things. Here, the bucket for us and the opportunity can be indeed 2 billion by having a better and facilitating equipment that prevent injuries to happen. Overall, we also have figures of improvement in terms of environment, which in dollar figures are very little, but now there's also a lot of interest in trying to make our airport more greener, more sustainable, and better for the people to work. Also because we have a huge turnout of people that are working in ground operation, is not really an attractive place to work. So by introduction also, automation, digitalization, we will introduce maybe more skilled people that need to work in operation with a better salary, better pay, better retention. I am mostly finished, so I will go to the last piece of my presentation. What are the challenges that we see? And of course, if we introduce technology, particularly on equipment, we need to be smart enough to trying to maintain here an environment where we can move technology, but the way we communicate data will remain within an ecosystem. So do not fit everything into one single technology that can be today the radio and tomorrow another technology, but just maintain here an infrastructure and an umbrella where you can do from full manual to full autonomous without disruption, depending on the pace an airport or the country can introduce those technology. In some cases, we have seen that there's a little bit of resistance from the line to buy in on taking them into the next step in automation and digitalization, understanding the power of data. Data ownership, of course, can be an issue, especially for data privacy and data protection in some countries. Who was owning the data? The airport, the airline, the ground handlers, actually all of them. So protocols of data sharing and agreement need to be reached mostly locally, but we can also establish some best practices on what type of information can be shared and to whom. Regulatory resistance to the change is something that we need to work with the regulators. We have experienced in the past that the introduction of technology sometimes is not accepted immediately. So in the process, we need to be smart enough to understand if today I have a load controller that signs a load sheet, tomorrow everything can be done directly by a system with no load controllers. If we have the same controls in place and we can demonstrate the safe and the process is in place, like today I have a driving license of a guy driving a ground support equipment, tomorrow I can have an autonomous vehicle who's controlling the vehicle. So if we have the same process and we can demonstrate that we have control in place, we can bring regulators on board to introduce this automation and innovation. The technology phase out prior adoption sometimes is another issue. We see with our phones goes out of date after 3-4 years, and there's always a need of a new technology to replace an existing one. So key is to maintain an ecosystem that can introduce new technology without being, the key of eventually dismissing the one that has been just established a few years before. So we need to work as an industry all together to understand also and how to overcome this issue. And with that, I think I have finished with my piece. I got a little bit over the 10 minutes. So over to you, Ian, for all the rest of my colleagues to go and presenting better the solutions and the key solution, how we can do it.
Thank you, Massimo. No, I think it's amazing to see how much can still be done, especially on the aircraft stand. All right, then without any further ado, Doc, please take over.
Thank you, Jan, and thank you, Massimo. From our perspective, the aircraft stand of the future will be characterized by effortless human connection, and that means both human to human and human to machine. And so if we move to the next slide. So we wanted to walk through kind of our vision of how collaboration technology will play a role. So first, no matter the artificial intelligence, no matter the IoT integrations or the business processes that you have powering to turn underneath, we believe every single crew member will be connected via one unified collaboration platform. As tech-savvy millennials comprise an increasing number of aviation jobs, each member of the term will come to expect real-time information flow and the ability to connect digitally with their colleagues, both on their mobile devices and on the wearables. We believe this will be especially true as we emerge from this, the world of COVID-19 lockdown, in which Zoom, which we're all in today, and other technologies have really simplified the ability for all of us to connect anytime and from anywhere. So the next bullet. So on a common platform, as Massimo shared, information flow is critical. So if everyone is on a common platform, information will flow to the right person at the right time and through the right medium, which could be text, voice, or even video. The next bullet, if we go through. With that collaboration platform also doubling as a workflow allocator, and with the crew members interacting with it throughout the day, it will be in a position to collect the highest quality and the largest quantity of data to push down the stack to the AI and business intelligence layer that will support machine learning and feature optimization. Cool, so we can move to the next slide. Massimo already hit on a lot of this, but we just wanted to share some stats from the US where we're based. Of course, you may be wondering why this is such an important issue. Well, as Massimo shared, and as you can see here, the costs are significant. Similar to what Massimo shared in the EU, the DOT data shows that in the States, controllable airport operation defects account for roughly 33% of all flight delays. And when you look at that from a comparative standpoint, it stands only behind ATC and system delays. It's actually the #2 reason for delayed flights in the United States. And when you look at the cost of the delay minute, around $75, And you really think about it, it's ineffective collaboration at airports that accounts for this big loss, which to US airlines is over $2 billion a year. And as Massimo shared, and as the industry has really picked up, over the last decade, the costs here, they extend far beyond the financial realm. Improved airport collaboration also reduces aircraft fuel burn, which helps us all chart a better path towards zero carbon aviation. We'll go to the next slide, and it won't be a surprise to many of you that have spent time on the airport ramp, but as to why this is the case. But we wanted to share that even from a simple narrow body operation, you may have a couple dozen people performing different functions. They all need to come together as a single team to complete up to 100 tasks in synchronicity in as little as 40 minutes. To further complicate things here, the team members work for different companies. Given the matrix supply chain that supports airport operation, you could have up to 10 different companies represented in that turn. And again, for those of you that have spent much time out on the ramp, it's not uncommon to have these 24 people literally appear from nowhere, work together for maybe these 30, 45 minutes, and then just as quickly as they came, they disperse back to their respective tribes. On the next slide, you'll see that as aviation leaders, we haven't made this any easier. So first, from left to right, despite how the passenger experience has been digitally transformed over the last decade, crew members working on the ramp still largely live in an analog world. Even with the ubiquity of smartphones, even with the improved connectivity we've seen at airports worldwide, two-way radios remain the primary plane-side communication tool. And that, of course, is going to limit any type of machine to human interaction. And by definition, it's going to limit our ability to capture good data around what's happening at that turn. Second, this, again, probably not a surprise, but when you think about the turn operation, we need to make sure that we break out of these communication silos. Although you'll have some teams working together, maybe you'll see, obviously the flight attendants and the pilots will work together. Maybe some components of the below-wing crew, those teams will work together. But for the most part, everyone's communicating with their individual group. So we need to make sure that that communication cuts across so that everyone can work together real time. And finally, at the far right, we wanted to convey was, again, this matrix supply chain that you see at the airport. If cross-team communication is an issue, it's not, cross-vendor communication and collaboration at the airport is pretty much non-existent. You have all these different companies, right, that come together for that turn, but they just don't talk with each other. So that's a critical issue when you think about efficient turns and collaboration. So in the next slide, we share, okay, so what's the solution? And so here we're seeing a world where everyone is on the same platform. And this shouldn't come as a surprise for us on this call. It's pretty much standard in any other business. We thought coming into this call, how silly it would be if some of us chose to participate on this webinar on Zoom, others on Skype, and others on Slack, right? It just doesn't make sense for us in the business world. So why in the heck would it make sense for the teams out on the ramp? They all need to be on the same platform. And in this vision, the platform cuts across different media. And so here, as you see here, it could be the web, mobile, wearable, IoT, but again, everything integrating up through this common shared interface layer so that the right data flows to the right people at the right time. The next slide, thanks. Just to share too, the collaboration in this space is different. And so again, all of us are accustomed to Zoom, obviously we're on this call. We all work with collaboration tools, but what's different in the space out on the ramp is that it can't be manual. And so we thought through how silly a concept it would be if, as the pilot is taxiing the aircraft to the stand, he has to spin up a Zoom call and invite all of the people on the ramp team, above wing, fueling, catering, to come together to collaborate. That's insanely crazy, right? And so in this world, collaboration is different in that we need to bring people together dynamically. And so there are a lot of challenges when you think about how to do that. But thankfully, if you're able to bring together the communication piece with the workflow allocation piece, you have the right properties to bring this group of people together. You'll know that the user on the platform is a pilot. You'll know that she is working this flight at this airport. You'll also know the fueling vendor that works for that airline at that airport, who the fueler is that's assigned to perform tasks on that flight. And so it's the data models is fairly complicated, but there's a way to seamlessly real time for, could be 45 minutes, an hour, whatever the length of that turn is, to bring everyone together on this platform. And with that, finally, again, through text, voice, and video, again, bringing back the COVID-19 lockdown, we saw things were moving this way, but now it just seems that people will be accustomed that if they want to, they should be able to communicate real time via video, a ramp team member with the pilot or with the flight attendant to communicate, collaborate real time. So what we thought we'd do is to provide a little meat on the bones. We'll close by giving 2 examples of how this collaboration works today with the limited tools provided, and then how things work in the future and the benefits you'll see. So the first one we wanted to share is the gate check bags scenario. And so just to set the stage, this involves a few different groups: the flight attendants, the gate agents, and the ramp agents. And again, you'll see the asterisk. It's fairly likely that team will be outsourced to a vendor. But here the issue is, of course, as the overhead bins become full, personnel need to ensure that the bags are gate checked. And once the gate check bags reach critical mass, as you can see that they are here at the end of the jet bridge, a ramp team member needs to move up, collect those bags, and then board them. And today, the way it works without an effective collaboration strategy, the flight attendants will be the ones responsible for determining when the bins are about full, either via the telephone at the jet bridge or walking all the way up the jet bridge to the gate. They'll tell the gate agent that they need to begin gate checking the bags. The gate agent's then going to need to manually make an announcement on the PA. Meanwhile, you're going to have 2 scenarios, one of 2 scenarios on the ramp. Either you're going to have a ramp agent stationed as a potted plant, literally just waiting at the top of the jet bridge stairs, waiting for that critical mass, just standing there inefficiently, or you're going to have them working out on the ramp, and then flight attendant or gate agent or someone will need to yell out and make sure that they come up and get the bags. So let's think about how this works in the future. Here you've got a video camera, data coming in, like from Assaia, that's going to let us know that we've reached the aircraft, has a certain capacity for overhead bins, and we've now reached 75% of that. The camera is going to know based on the bags that if they're accompanying passengers down the jet bridge. Once that's met, a notification will be routed to the gate agent, and they will know to begin gate checking bags. If you have an automated PA, that's going to blast it automatically, and so the gate agent won't need to do anything manually. At the same time, the ramp team member is going to receive that notification that gate checking bags has begun. As passengers continue to go down and bags are left at the end of the jet bridge, the camera will identify the quantity of gate check bags. Once that reaches a sufficient number, say 5, 6, 7, to the point where it makes sense to get that ramp agent, then the wearable on the ramp agent will alert, and they will come up and they'll be able to get the bags. And so with this process, you're going to see a more efficient information flow. You're also going to see productivity gains on the ramp. And most important, you're going to avoid the defects of bad communication leading to ramp agents getting those bags late. Lastly, a second example, and this one is close to home. Those of you that know us know that a lot of us were cabin cleaners back in the day, or oversaw cabin cleaning operations. So this one involves, we have 3 different groups and maybe a 4th, of flight attendants, gate agents, cleaners, and corporate health and security. And here the issue you can see in the photo is that during a turn, the cleaners discover that there's a big mess, possibly human fluid on seats. And so in today's world, they're going to be nervous. They're going to want to make sure that all safety and health precautions are met. So what's going to happen is the cleaners will, via radio, connect with their dispatcher. Their dispatcher is going to try to figure out what's up, radio the airline, hey, there could be an issue at the ops center. Through that, there'll be some confusion on the aircraft. They'll try to bring up additional cleaners. But over the next 10 or 15 minutes, everyone is going to swarm on this area trying to figure out what to do. Well, in the new world, simply via the mobile application, the cleaner is able to quickly notify everyone that there's a potential issue, maybe take a photo, maybe identifies that there's a potential human fluid issue. That information is routed immediately to everyone, including the corporate ES&H department, which if they want to, can get on the call and then via video, take a look at what's going on and determine whether this is a hazmat situation or not. And so you could see with all this different communication, collaboration, if you get everyone on that same platform, regardless of what systems live underneath, you can immediately route the information down and up to the right people, bring them together. And lastly here, most importantly, is make sure that everyone communicates and collaborates effectively real time. And of course, getting back to the benefits, reducing the cost of defect that we see manifested in delays, and for all of us to provide for a more carbon neutral world. But I think that's it. I'll kick it back over to you, Jan.
Cool, thanks, Doug. And I really hope that you didn't have to clean that particular seat area. Cool. All right. Thanks a lot. Very interesting stuff. Okay, last and again, not least, Nikolay, please go ahead.
Hey, everyone again. I will try to be rather short so that we're making it on time. But let me start with a complete off topic. So eye is one of the most powerful senses that has ever been created. Well, it sounds very obvious, but let's really think of that. You're watching the webinar right now with your eyes, which is great, but life is much larger. You're just one of the species on Earth. Earth contains a lot of different animals, and all of them are really, really different in terms of what they want to achieve. For example, a lion is just interested in hunting their prey, but maybe there is like more peaceful animal, which is just looking for a safe part of land where this animal can eat grass. There's also a bird which will maybe be hunting, maybe be eating grass, but would also be flying up and down because it lives in actually a three-dimensional space. Well, the point is all the animals have very different needs they need to fulfill in order to survive. However, we have seen that the majority of them have been relying on not on computer vision, but on their own vision, so essentially on their eyes, to make the goal achievable. Well, this is actually remarkable because it makes vision a very, very versatile tool. Well, it goes without saying that vision without the brain is kind of useless. For example, here you see some big cats hunting some buffaloes. I think it's buffaloes. I'm not very sure about that. So it's actually a very difficult analytical task. You don't only need to see the buffaloes, but you also want to understand which buffalo is the slowest, which one is the weakest, which one has the most fat, and so on and so forth, so that you actually do the proper optimal hunting strategy. Well, the cool thing, they rely on vision. And the cooler thing, we know this works, because otherwise these animals will not be with us today. So all the animals who rely on vision are actually still alive. So no, it's a very good strategy. And it's also very obvious because our world has light that is just reflecting from different surfaces. So it's a very, very natural, very, very versatile sensor. Okay, I think I'm done with philosophy. Let's try to understand whether it's actually can be applicable to some actual proper case. Well, for example, to a busy airport. The statement is, yes, it can be applied very, very well. And the same thing which happens in nature and is called vision and eyes and brain is translated into camera and computer vision. So let me show you a couple of examples to enlighten you on how many different things can be done if you just install a single camera on your ramp. So let's start with safety. Well, what you see in this, not yet, now, yeah, what you see now in this simulation is a plane arriving at the stand. What you maybe don't notice is that it's doing it incorrectly. So although the nose of the plane is already at the stand, you see that the plane is actually not very properly aligned with the stand. It still has some angle to the stand, which leads the left wing of the plane to go actually outside of the stand border. Well, this is very dangerous. And accidents of this kind, when a wing of the plane hits something, already costs billions of dollars a year for the industry. What is even more remarkable, if you see this bubble to the right, it happens in almost all the cases. We have done our own study and we have seen that more than 80% of planes are actually understeering. Well, this is a huge issue because if you want to make the stands more dense, which is very important because the land of the airport is very expensive, you have to do something with that. So let's suppose you want to monitor your pilots and want to monitor who is doing the proper oversteering and which pilot actually, so you just want to understand which pilots are doing oversteering. So You can equip your plane with sensors. You need a couple of GPS sensors to get the location and the rotation of the plane. But it sounds pretty painful to equip all the planes with such sensors and also get the data from that. But what is very cool is that if you have a single camera at your apron, you can solve the same problem using this camera. So modern computer vision solutions allows the camera to understand the 3D world around it, which essentially means that the camera will know how the stand is structured. And then the problem becomes very, very trivial. If you see the image on the right, once you know how the stand is configured, you can just know what traces do the wheels have to follow to actually bring the plane to the parking position correctly. And once you know these traces, it's very easy. You just trace the wheels of the plane. And if they don't follow the traces, well, then the oversteering didn't happen and the plane has parked incorrectly. So this is a very, very easy way of monitoring the very complex event. And essentially, the only thing you need is to install one camera at the stand, and you can get unlimited data, which works for every single turnaround, be it day, be it night, be it a long one, be it a short one, unconditionally of the plane type, and completely automatically. Well, another case which is similar and different at the same time is this speed tracking. A safety issue which we observe with multiple customers is that they want to understand the speed of the pushback action. So this is needed because usually objects on the stand are not supposed to move faster than a human speed, which is usually defined as 4 miles per hour. I know it's a bit deceiving in this video because it has the European metric system, but it doesn't matter. You just need to measure the speed. Well, again, you can just do it with a single camera located at the apron. And if you use computer vision in the end, after the turnaround has been, after the pushback of the turnaround has been commenced, you can get analysis like that. What is very interesting and remarkable is that it's actually a very valid problem. We have observed that almost 20% of towing actions are happening above the speed limit. So people are actually speeding quite a lot. What is also very interesting is that this case is extendable to a much larger case, because usually when you as an airport or as an airline want to monitor the safety, you don't really care about the speedback of a pushback action, but you also care about every object which can be speeding, every little truck, every little car, every little dolly. So the great thing is that if you have a camera installed at the stand, you can essentially measure whatever you want. You can measure anything which moves, you just have to program it, and then you get a full safety monitoring system which monitors everything you want 24/7 with just one camera. Feels pretty exciting to me. Well, that was the insight into safety. There is also one thing which is relevant to some of the people involved in the airline industry, is actually on-time performance, because that's essentially a primary goal of good ground handling. You want to have planes leave on time. So for that, you want to have as much information about turnaround as possible. And the great news is that computer vision is a perfect tool for that. By having 1 or 2 cameras at the stand, you can actually get all the relevant information you need about the stand, about what's happening to the stand, to the aircraft in the system. You see here an example of a Assaia system running in real time at one of the airports. And what you see is that it's constantly delivering timestamps, which are of very high quality, which are, what is important, free of any bias, because we know that human timestamps can have some bias, and which are delivered continuously. Well, the great thing is that having this information, you can on one side predict when the plane will leave, which is essentially important for many tasks, for example, stand allocation. What you can also do is to control the turnaround. And if you see that something goes wrong, you can still maybe fix it and save the turnaround from being late. The information that Assaia is providing is essentially free to be integrated with any other source of information. For example, we integrate with Springshot. But what is very interesting about this information, and that's what I wanted to show on this slide, is that we really collect information from different agents of the process. So what do I mean? Here you see an example of catering and fueling activities. What usually happens on the ramp is that although you have some turnaround, some ground handling provider, fueling and catering is happening with different suppliers. So monitoring their performance is very difficult, both politically and engineering-wise, because you need to collect the data, you need to get it real time, and it's just a huge mess. However, you just care about turnaround as a holistic process. So what happens is if you have a camera which observes what's happening to your aircraft, you can essentially monitor whatever you want. And in this case, you also see, for example, catering and fueling directly integrated to your system, so you get all your relevant data absolutely magically just with 1 or 2 cameras installed. Well, I think this more or less concludes this short demo of computer vision I wanted to make. I wanted to highlight that although we're talking about the ramp of the future and the technology still looks pretty futuristic to me, although I'm essentially a computer vision guy, this is not the future, this is the reality. Computer vision is already available today. Assaia is an excellent example of that. So very excited, very, very excited about that. Thank you very much. I think, Jan Willem, you can lead the Q&A now.
Thank you very much, Nikolay. Yes, so we already got some questions in the meantime that were already answered, but I think, Max, you had a question that you wanted to raise towards Massimo, correct?
Yes, exactly. Thank you, Jan. So this is a question that came to my mind during the webinar because we were talking about those huge, potential billion-dollar savings, and I think that's really impressive potential. So that's on the one hand, right? On the other hand, we're now seeing in these times of crisis that airlines are struggling for survival, right? And the reflex, the knee-jerk reflex reaction is we need to save as much money as possible for an airline. So given the fact that this campaign is called Rebootaviation, I assume we have a number of agents of change here that really want to bring ground handling to the next level in our audience. Massimo, do you have some advice and tips you can share how to actually convince airline executives to make the right investments into ground handling, and ideally make them now, because now is a pretty good time to actually change operation processes?
Well, I think we need to look at the situation before COVID, during COVID, and after COVID. I mean, if you look at the situation before COVID, there was, here huge demand of improving here the operation and efficiency. Now, when we have such a big disruption in terms of economical disruption too, I think here now the focus is on surviving first. So trying to recut and reduce the cost as much as possible. And then when you restart your operation at full pace, then you might have maybe more opportunity to see how we can bring back the efficiency and improve your efficiency into your operation. So it's a very delicate moment, a very difficult question to answer. But what I think is that for restarting, it's restarting with simple things, use a common standard. In IATA, we push for standardization. So trying to use common standard, like in our case for operational procedures, we are enforcing and we are promoting the use of the IATA ground operation manual or common training, common things. So this is what we are recommending. When the operation is going to be back at full pace, well, that maybe there would be more chances to see how can we improve and cut our costs. And that's indeed sometimes with the right investment for the equipment, for the technology, those can be thought and can work together. It's very difficult now for all stakeholders to do investments as they are incurring a big loss of money. But I'm confident that when the COVID crisis is going to be over, most likely 2021 will tell us how fast we will be in recapping the normal, allow me to say normal situation. That is now in a moment where it's very difficult to understand the flow. How and when we'll go back in at a full pace.
Cool. Max, did that answer your question?
Yeah, tangentially. Thank you.
All right. We have one more, or we have another question from Chris Griffin. Nikolay, I think this one is for you. He asked, can the feeds from existing cameras be utilized for the camera vision purpose?
Yeah, thanks. Excellent question. We get asked that a lot. Yes, absolutely. You can use the existing cameras. So essentially a computer vision system consists of a camera and some some processing unit, which can be either like a little computer, which is located at the airport, or just simply a cloud solution. We very much can use, and in general, you can for sure use existing cameras. It is important that the camera is located properly, but our experience shows that the majority of cameras are located in a way that you can capture quite a lot of data. If you're interested in specific cameras, I would be very happy if you would shoot me an email to later on after the webinar, and I can do some assessment for the camera screenshots that you could provide.
All right. Any other questions? Oh yeah, there's one more. Sorry if I pronounce this name wrong, but I think it's a very difficult one. Przemek from GTAA, if I remember correctly. Did your cost study distinguish airports with implemented ACDM and those without? I think this one goes to Massimo. Yes, perfect, thanks.
Can you repeat the question? Sorry, I lost a little bit.
Did your cost study distinguish airports with implemented ACDM and those without an implemented ACDM?
No, it is a very general and is just taking into consideration the overall cost, and then we have a projection for the traffic growth. So of course there's a difference between, airport and airport, location and location, indeed. But we are looking at the figures for ground damage that we have collected over the last 5 years. And overall, in terms of delay, the forecast has been done by using data and stats from delays from Eurocontrol. And then we have used this percentage, which represent about 30% of the overall traffic into worldwide as a projection. So no, we don't have a defined study difference in the two. And I do believe that a CDM will help a lot in reducing these delays and situations.
Cool, thanks a lot, Massimo. Any further questions from the floor? All right, then Massimo, I have one maybe. Oh, well, there's one from the floor from Simone. Hi, Massimo. Did the data report reported any reduction of ground damage when IGAM were implemented?
We don't have this figure yet. We want to capture that figures. So we consider that 15% of the overall cost can be reduced, whether you're looking into injuries, damage, and efficiency, by the introduction of standardized operational procedures. So the overall saving that we can consider about the use of standard that are common standards is around 15% of the overall turnaround cost. But in terms of damage, no, we don't have this distinction at this stage, but we wish to, once we have a better timing, we wish indeed to capture those figures on key studies where the IGAM is fully implemented.
Right, thanks a lot. Massimo, I have one follow-up question on this one. You mentioned several opportunities that airlines, airports, IATA, the whole industry can take on in order to reduce these costs, to improve the whole stand of the future. In your opinion, what are the opportunities that can be achieved on a short-term basis?
Again, is a difficult question because of what we are living right now. I think that the automation, in terms of automation, what we think is that the first things we can achieve is the mobility, automated mobility, meaning moving things from point A to point B. And the phase 2 will be likely instead to be interaction and integration with the aircraft. Is going to take longer because it includes also the aircraft manufacturers, the airline. It's a bit longer process of this integration, and that is for mobility. As far as concerned instead digitalization, I think we have some work in progress into our ground operation and automation digitalization working group, which is automated load control, automated communication between loading and load control, and also timestamps turnaround, which we have shown, creating a standard that can work for all the industry and not just, for one or two people. So that is in the short term, I think we can deliver some standards that can be immediately used. As far as concerned the overall concept, it depends also on various situations, mostly related to investment. Of course, airports that are more advanced will be the first one to invest more money. It is a bit difficult now to forecast when investment can be done, for the reason I'm mentioning, that in a crisis, the overall scope is surviving and rather than investing. So that's where we can be able to fast restart our aviation. I think this is a key, how fast we will be able to restart aviation. And of course, in these terms, regulators and states play a major role.
True, very true indeed, yes. There's one more question from Jörg Merke. How is, and Nikolay, I think that goes into your direction, how is the GDPR taken into account when using the cameras to measure and report actions of individuals?
Well, the dealers would take it, of course, very seriously. When you work with CCTVs, you have to think about GDPR, of course. So we don't care much about actions of individuals to the level we try to always blur the people out even before it comes to any processing. So whenever you see a dashboard, whenever you see any kind of video from our system, you definitely don't see individuals. It's more like on an action level. This is how we protect the privacy of people with the GDPR standards.
Yeah, well, I can tag on to that one too.
Yes, please go ahead.
So obviously, you already see, in Germany, certainly in the EU, Germany, there's absolutely heightened sensitivity around location data. So we'll share that, before our platform is ever implemented in the EU or in Germany, specifically in Germany, we'll sit down, or a partner will sit down with the Works Council. We'll make sure that they understand what's going on, and if there's an issue, our platform can still be used, but we'll cut out the location data, which is a critical piece. We'd love to have that data, but it's not absolutely necessary. Without that, you're going to rely on the human inputs. But we've been successful when that issue's been raised to say, look, that data will be helpful for you. One, if we have that location data, it's going to allow you to protect. It's going to show you're doing a good job. There's going to be an objective record that protects you. And two, you're going to benefit from having all these other inputs from all of your colleagues that just flow in for notifications. But we'll say we never, outside the EU, we have a lot of partners that like to see pins on a map. Certainly in Europe, Germany, that's something that normally we don't do. But to share, as Nikolay shared, we're all very focused on making sure it complies to GDPR.
Just to triangulate that from the commercial side of Assaia, Nikolay already described the technical measures that are very strict. So it is a concern in the beginning in any conversation. I think that's also what Doug said. What we usually find out is that the system is not really suitable for a so-called Leistungs- und Verhaltenskontrolle. That's right, the bad words for the unions and the worker councils. So ultimately, we always found a solution. Again, echoing what Doug just said, because ultimately we can show that the system is designed to make operations more efficient. And that is also the spirit when it comes to improving individual operations. It's never the individual that's going to be blamed. Couldn't be, because it's not identifiable. It's always, if something is not going well, it's the rationale of our customers is always, okay, what can we improve in training to actually generate better processes, more efficient processes. So ultimately, everyone benefits because operations get safer, more efficient, and all of that on an organizational, not individual level.
All right, thanks, Max. Then there's actually two further questions. One is from Chris Griffin. Nikolay, this one is for you. What other industries do you see this application being deployed in?
Yeah, Chris. So Essentially, our technology is the closest other industries where you can apply our technology is whatever is related to logistics. So warehouses, ports, railways, and so on. However, as I've said before, computer vision is so versatile. There's almost every industry is somehow affected by that, starting with medical, ending with self-driving, and so on. But for our industry, it's mostly logistics. For our technology, it's mostly logistics.
We actually did a separate webinar that covers these topics very well. So if you check out our YouTube channel, you will find the first webinar, and there's tons and tons of different use cases.
Very enjoyable. I was talking there for half an hour about it.
Very enjoyable indeed.
And you had a better haircut at that time. Perfect.
True.
We have one more question from Marvin Koenig. Doug, that goes into your direction. At the gate, the reaction time is very low. Wouldn't it be better to separate as much as possible bags before the gate, for example, before security control, to avoid the problem that someone, most of the time the people boarding the last rows in the plane, have to give their luggage into the belly in the last minutes before departure? And at the gate, the reaction time is very low.
Absolutely, yeah. So we share that as just one of dozens of examples of different teams collaborating together. But certainly whatever we can do ahead of time to separate the passenger from the carry-on bag, certainly when we understand that the overhead bids don't have the capacity for that bag, that's always a great thing process-wise. So absolutely, that's a great idea.
Cool. All right. Well, thank you very much, everyone. Nikolay, if you can maybe go to the last slide, please. So it was a great webinar, in my opinion. I really loved the questions that you interacted. In case you want to contact us, here's a little overview. As I said, we will also reach out to you again with the link for the video of the webinar. If you have any further questions, either to Doug or to Massimo or to Nikolay, feel free to shoot out to us. Thanks a lot for participating, Doug and Massimo. It's been a great pleasure having you on this webinar. And look out for some future webinars that we will announce shortly on LinkedIn. Thanks a lot and have a nice day.
Thanks, everyone.
Thank you.
Thank you, everyone. Thank you, Massimo. Thank you, Doug.
Bye. Thank you.